Hello. So in this session, we want to solve this particular question, which is asking us to find the limit as x approach to, let me do 3 first. As x approaches 3, x approaches 2.5, um, x approaches 2, and x approaches 1. So when we are talking about the x, right, this particular function, the function is called the g of x. So y is equal to g of x. G of x is the name of the function. And when we're talking about the x-axis, basically the y are the vertical lines here, and the x are the horizontal lines here. So we'll be reading from both sides like that. Okay, so we are asked to find the limit as x approaches 3 first. So what to do, like go on the x-axis, right? So where is 3? 3 is located here. For that one, draw a dashed line through that. Let it be like a transparent line, or you can call it an imaginary line through the value that is approaching, which is 3. Now look at the function itself. The function is g of x, right? This is the graph of them moving like this, like this, like this, right? That's the entire function. And one jump slide, it has a jump, so it's a piecewise function. It's a piecewise function because generally the function appears in pieces, right? In pieces, something like that. Okay, so we know that our imaginary line or dash line passes through here, and where does it cut the function? This is the function, which is the blue line, right? You see that our this thing cuts over here, they meet over here, somewhere over here. So that's where it cuts. So now let's focus on the function. The vertical line separate this line into two sides, this side and then this side as well. Now if you are moving from this side towards the point, you have to be on the function. Don't just be anywhere and they say you are moving towards the, no, you have to move on the function. The function is just like the route or the path that you have to move on. So we are going to be standing here and be moving, just move on the function. To move on the function, then to get to the intersection between the function and the y and the vertical line that we drew, the imaginary line that we drew. See it as our destination, right? Okay, let's also do it on the other side too. Let me clean this one. So if someone is also here, the person needs to move to the destination. The destination is the intersection between our imaginary line and the function itself. You see that when the two of them, if you are moving from either side of the function, one person come from here, one person come from this side of the vertical line of our imaginary line. What happened that it's like they are all approaching the same point, right? They are all approaching the same point, approaching the same point. So that value that they are all approaching together, if you have to read it from the y-axis. So the y-axis is the limit value, is where you read the actual limit value from. The x-axis is where you put your imaginary line from on. Use the x-axis to know where to put your imaginary line, and then the limit value at that point will be read from the y-axis. So over here, you see that the two of them, the two arrows are pointing to the intersection is here. So when they came to that destination, you see that the two sides are reading the same value. They are approaching the same value. All that value that they are all approaching. I think this one is the origin, so it's 0. So if you have to read that on the y-axis. On the y-axis is the 0 value here, right? Because 0, 1 going. I think 2 will be somewhere here, but they are all approaching the value on the end. On the y-axis, that value is 0. So for that matter, the limit as g of x g of x as x approaches 3, right, is equal to 0. So 0 is the limit value. Let's solve for the next one. So we are done for 3. Let's go to the other one. So we do the same exercise. I use the first one to explain. So basically, if you are moving next time, don't waste time. What you have to do is that now they say x approaches what, 2.5. So 2.5, oh, let me clean this side wall. Where is 2.5? So go on the x-axis, right? Go on the x-axis. Here we have the 2.5. Go on the x-axis, and I think 2.5 will be somewhere here. Go on the x-axis first. Draw your imaginary line until it cuts the function. Until it cut the function. There's no side of the function down, so we don't worry much. Until it cut the function. So it's cut the function somewhere here. So this is our new destination now. So now go and sit on the function. Go and be on the function, right? The function is the graph, the blue line itself, right? And move from this side towards the destination, that's the intersection, and be on the other side too and move towards the destination. Now you are all when they are all coming to the destination, they are all pointing at the same valley at the destination, right? They are all pointing to the same destination. So what we have to do is that you have to read that valley on the y-axis. We say that the y-axis is where we read the limit value. So the limit value are actually here. So this is somewhere like 0.5. If this one is 0, 0.5, 1 going. So yeah, so the limit of g of x as s approaches 2.5 is going to be 0.5. This is what we found, right? That's okay. That's good. Let's read another thing. You can try the other one that I put there on the board, right? I'm talking about. Now let's go to s is equal to 2. We are done with s 0.5. S is equal to 2. So you go through the same exercise. Vertical line. So our s is 2, right? We need to draw a vertical line through that. So the vertical line through that, imaginary line through that until it cuts the function. There's no side of the function down, so we don't worry much, but we carry out at the top. So you see like you cut it over here, right? So you sit on the function, like on this from this side, you move on the function. The function is your path, so until you get to the destination. For this side, you also move until you have to move towards the destination. Until you move, you have put the destination. Now that destination value, what value on the y-axis are already there. So the thing is that both of them are pointing at the same destination, right? So now we have to read. We have to read. So this one is clear, is 1. So the limit of g of x as s approaches 2 is equal to 1, because that's what you read from the y-axis. Y-axis are the limit values. This is where you read the limit values from. The next one, let's talk about, I say s is equal to 1 now. Now s is equal to 1. So if s is equal to 1, you go there, this s is equal to 1, you draw your imaginary line, imaginary dash line towards that s is equal to 1. Then you sit on the function from this side, So we move towards the destination, right? Now this side, we want to move towards this destination, and then the destination, you see, it cuts in this case, right? This one cuts the function at 2 points. This 1 point, this another point. It cuts at 2 points. You have to note that. So the imaginary line is cutting this side at 2 points. So what I have to do is that this guy is going. I have to sit on this function. This guy goes and then when it comes here, this guy is reading what value on the x-axis, on the y-axis, sorry, is 1. And this guy, when he's coming down, what value is he reading over here? He's reading the value 2. The value is 0. The value is 0 here. So they are not reading the same thing. They are all not reading the same thing. From either side, we are not reading the same thing. So the limit does not exist. Does not exist. The limit as s approaches 1 of g of x does not exist. Yes. So the trick is that when you do the dash line first and you see that the dash line is cutting the function into 2 parts, it's cutting the function, is meeting the function into 2 parts, right? Then you have to know that it should give you an idea that the limit value does not actually exist, but you have to show that on either side. So on the left side, we are reading 0. On the right side, we are reading 1. So 1 and 0 are not the same. Since they are not the same, that's not the same destination, so we just ignore it and say the limit does not exist. Yeah. In the next one, we bring another function and solve another function again and see how to go about that to solidify the concept that we learn in this session. So basically, stay with us so that we can solve the next one.